For the average person who sort of was hoping to see a picture.
I obviously don't have an astronomer's eyes. What are you really seeing with these images?
Is this actually how it looks compared to how we actually see it?
How long does it take to sort of process these spectacular images from infrared?
Why is that better than a picture?
Not everybody can be a robot polisher.
So I think there's a good bridge here to make between science and arts.
Astounding detail that you can see in some of these galaxies.
Makes the invisible visible. In infrared, we can't detect it with our human eye.
You're going to take the light and break it up into a rainbow and look very, very carefully at how much color is coming in each part of the spectrum.
Do you know what spectroscopy is?
Carina Nebula here, that image was really designed. We spent probably a couple of weeks on each image end to end.
Also part of the stories that we're able to tell the structure of the atmosphere, not just what's in it.
It's just a little pattern going on here, 6, no big deal. Yeah, so it's just really amazing, all of the detail and all of the galaxies.
Is this sort of marriage between art and science?
And so you can think of it much more as a translation of a language you don't understand. Who had infrared eyes that were sensitive to this light? This may be what you would see.
So what they really do is they take the light that's coming in and it splits it up in its colors.
It's almost like something out of a film or out of something that someone had created graphically.
You know, just like a prism looking at the sun that splits it up in colors. That's what we're doing with these spectrometers.
Yep. Okay, and yeah, love it. Love to see it.
Recently, I went and had an ugly cry, okay? Going and having a little sob because it worked.
Like a transformer in the movie.
There is a lot of aesthetics that and attention to detail.
You zoom in on it and you zoom in and you look at details that every detail you see is going to be real.
Level of detail, like at the pixel level.
This is an art piece, this thing.
Just love that it's so real that it looks fake. Love to see it all over the place. This image is just incredible. I mean, our universe is just so amazing. It's just so incredible.
I can tell you how many oxygen atoms there are in that galaxy.
To the untrained eye, this is a red speck.
There's a real bodies. They're interesting places out there, and they're real.
But to the trained eye, this is why we built this telescope.
I think we'll just have to wait for scientists to get at the data and go, work it with their models to learn more.
They're real.
Once the experts get a chance to look at the raw data.
A bunch of what looks like bumps and wiggles, but it's actually full of information content.
And can you believe all of that was done while navigating the telescope to its ideal position 1 million miles away from Earth?
We're looking back more than 13 billion years.
Back into time, into the Big Bang, just after the Big Bang happened, looking into galaxies far away. It took light billions of years to get there.
Let me say that again. 13 billion. It's hard to even fathom.
And it's impossible, but we did it.
The impossible possible.
It's astounding to me. I mean, it really is.
We had to invent things along the way, so we did that.
We're understanding the composition of things based on light.
What's just said, I'm in tears looking at it because it's so beautiful. So you can convince yourself that you see what's in these galaxies.
You can convince yourself that you see what's in these galaxies. Not everybody can be a robot polisher.
And this science gets even better with each passing mission.
100 years ago, we thought there was only one galaxy. Now, the number is unlimited.
They want you to feel like nothing. And people do. Mission accomplished.